Okay, guys, yesterday we talked about adding and subtracting rational expressions. And when we talk about rational expressions, all that is a grown-up way of saying a fraction. So remember, when you add fractions, you have to have the least common denominator. So we're going to have to get common denominators with the following problems. These are a little bit harder, so we got to remember these simple rules. You have to have the same denominator. You have to make sure you factor everything first. We're going to find the least common denominator, multiply each term by what's missing, then add or subtract the numerators. Let's go through a couple problems. We did 5 and 7 yesterday, so I'm going to go ahead and do 6 and 8. So it's really easy when the denominators are completely different. I like to put parentheses around my expression so I remember that x is completely by itself and then x plus 1 is stuck together. So those two things are very, very different. So what would be a common denominator between x and x plus 1? Well, in this case, we're just going to multiply them both together. I'm going to put them both down in the denominator, x times x plus 1. And then to evaluate our numerator, we look at, or our problem, we look at the numerators of each fraction. So my first fraction, in order for it to look like this for a denominator, you look to see what the fraction has and what it's missing. It already has an x in the denominator. It's missing the x plus 1. So if I multiply this bottom by x plus 1, now the denominators are the same. And what you do to the bottom, you have to do to the top. So I'm going to multiply the top by x plus 1. Now I'm going to look at my second fraction. What do I have to multiply this by so it looks like this? Well, it already has the x plus 1. I have to multiply it by x. So now the denominators are the same. What you do to one fraction, you have to do to the other, or the top. So what you do to the bottom, you do to the top. So I'm going to simplify and say, okay, distribute here. I have x plus 1, then I have a plus sign. 1 times x is x, and we combine like terms. We're going to just simplify our numerator. Your denominator stays as x times x plus 1, and then I'm going to combine like terms. 1x plus 1x gives me 2x plus 1. And then I look to see, is there anything that I can factor? No. Is there anything parenthesis-wise on top and bottom that's exactly the same? No. So my answer is right here. All right, moving over here to number 8. I'd like you guys to kind of pay attention to what you're looking at. Before you just start multiplying and adding and all that stuff, look at what you're working with. First of all, you see that your denominators are different. So I'm going to put parentheses around both of them. There's nothing I can factor out, so that's good. And I do notice here that I have a minus sign in the middle. I'm going to go ahead and change that to a plus and then stick that minus right there because you're going to have to distribute that negative. So if we change it to a plus in the middle and then put the negative real close to the number or letter, sometimes that helps us not to forget. So when I look at my two denominators, they're both completely different. So I'm just going to stick them together. We're going to multiply them together on the bottom. So x minus 3 and 3x plus 4. So I look at my first fraction. My first fraction in the denominator has the x minus 3. What is it missing? Well, it's missing the 3x plus 4. So what you do to the bottom, guys, you have to do to the top. So I'm going to multiply the top by 3x plus 4. Then I look at my second fraction. It has the 3x plus 4. It's missing the x minus 3. So what you do to the bottom, you do to the top. And now all of the denominators look the same. So we're going to just evaluate the numerator. X times 3x is 3x squared. X times 4 is plus 4x. Negative 2 times x is minus 2x. And negative 2 times negative 3 is plus 6. So we're going to rewrite our denominator. Our denominator just stays the same since we found what our common denominator was. And we're going to combine like terms in our numerator. So I have 3x squared. Nothing else has an x squared. I have a 4x minus 2x gives me plus 2x. And then I have plus 6. So now the last thing we need to do is see if we can factor. If I multiply a times c, I get 18. Are there factors of 18 that are going to multiply to give me 18 but add to give me 2? And your answer there is no, so there you go. There is your simplified addition, subtraction of those two fractions, those two rationals. All right, moving along. Again, we only have 3 more examples. You guys are doing a great job. Again, assess kind of what you have going on here. One denominator is 2x minus 1. 1 is x plus 2. There's no factoring that you can do there. You can't simplify, take anything out. So just put a hug around it. And then I see this minus sign here. So I'm going to change this minus sign to a plus and stick that negative right there in front of 1 so I remember to distribute. So my common denominator between these two completely different things, we're just going to take each one of them and stick them together in the denominator. So x plus 2. Good. So my first fraction in the denominator has 2x minus 1. It's missing the x plus 2. So I'm going to multiply the bottom here by x plus 2. Well, what you do to the bottom, guys, you do where? To the top. My second fraction has the x plus 2. It's missing the 2x minus 1. So again, what you do to the bottom, you do to the top. So now all of our denominators are the same, so we can just work on the numerator. FOIL, or multiply. X times x is x squared. X times 2 is plus 2x. Negative 1 times 2 is minus 2x. And negative 1 times negative 1 is plus 1. So we're going to rewrite our denominator, 2x minus 1. And x plus 2, and then in my numerator, I'm going to combine like terms. So I have an x squared. Right here, I have a positive 2x and a negative 2x. Those are going to cancel, and then I have plus 1. And the last thing we do, guys, is look to see, can we simplify, can we factor? X squared plus 1. Some of you are going to say, yes, you can break that down, but you can't, because that's not the difference of squares. If there was a minus sign there, you absolutely could. But x squared plus 1 just stays just like it is, so we're going to circle it and move along. All right, let's go down here to number 10. All right, let's talk about what we need to do. We got to put a little parenthesis around both of our denominators. And I notice here with x squared minus 9, wait a second, that should, bells and whistles should go off, guys. X squared minus 9, I can factor that. What can I factor that into? X plus 3 and x minus 3. That's the difference of perfect squares. So now I look and I say, okay, we have a little bit of a unique situation here because both denominators are kind of similar, but they're kind of different. So when you have a case where one denominator has something in common, but then the other one doesn't, you're just going to write down, first of all, the thing that they have in common. So they both have an x plus 3. And then we're going to write down the thing that they don't have in common, which is the x minus 3. But you only write each one time because you want the least common, not just the most common. So now we're going to get equivalent denominators. My first fraction, if I look at the denominator, x plus 3, x minus 3, it already has everything it needs, so the 2 just stays. My second fraction has the x plus 3, it needs the x minus 3. So what you do to the bottom, you do to the top. So now that all three of the denominators are the same, we are just going to work with the numerator. So I have plus positive 2 plus 4x minus 12. So we're going to rewrite our denominator, x plus 3, x minus 3. And we're going to combine like terms in our numerator. I have a 4x, and then I have 2 and a negative 12. So 2 minus 12 is negative 10. And then we look to see, can we simplify? Can we factor? Can we do anything? And I notice, you know what, guys? There's a GCF in my numerator, isn't there? What number goes into both 4 and 10? 2. So when I divide out of 2, it doesn't go away. It just moves to different spots. So my 2 comes out in front. I'm left with 2x minus 5. And then on the bottom, I have x plus 3 and x minus 3. And we need to look to see, are there any parentheses that are exactly the same on the top and bottom that I can cancel out? And there's not, but there you go. That's your most simplified form. And last one, number 11. All right, number 11, same kind of problem. Now we just have 3 fractions to deal with, but no big deal. My first denominator is x plus 1. My second denominator is x minus 1. I can't factor anything out there. But my third one is x squared minus 1. So some of you are like, oh, wait a second. Isn't that the difference of squares, x plus 1, x minus 1? And you are correct. So now in order to get a common denominator, I see some things are similar, some things are not. So I'm going to first write down something that they have in common. Well, 2 of the 3 each have an x plus 1. And 2 of the 3 have an x minus 1. So somehow we can manipulate this to where they all have the same. So I look at my first fraction, and I see my first fraction has the x plus 1. It's missing the x minus 1. So what I multiply on the bottom, I'm going to multiply on the top. My second fraction has the x minus 1. It's missing the x plus 1. So what I do to the bottom, I do to the top. And my third fraction already has both of them, so I leave it alone. So now that all of our denominators are the same, we work with just the numerator. So I'm going to FOIL, multiply, distribute, however you want to say it. 2 times x is 2x. 2 times negative 1 is minus 2. Plus 2 times x is 2x. 2 times positive 1 is plus 2. And then I have plus a 1. So again, we're going to rewrite our denominator. X plus 1, x minus 1. Once we get a common denominator, we just let it hang out. We just keep carrying it down. And we're going to combine like terms. So I have a 2x here and a 2x here. Gives me positive 4x. Positive 2 and a negative 2 are going to cancel. And then I have plus 1. And I look to see, are there anything that I can factor out at the top? Is there a GCF, anything like that? No. I don't have any parentheses that are exactly the same on the top and the bottom. So I know my problem is simplified. So now, guys, please go ahead, pull up your homework. I need you to start working on it. You really, really, really have to practice this stuff. We're going to go over more of it tomorrow in preparation for your quiz, which is going to be on Friday.